Glitch, it's time to educate the masses. Why don't you brief them on our spatial transposition drive?
The general logic interface with tachyon coprocessor heuristics is now online. Accessing Spatial Transposition Drive, STD. The Spatial Transposition Drive, or STD, is the means by which spacecraft engage in faster-than-light travel across the known galaxy. Although STDs are incredibly complex technological marvels, their method of operation can be explained in relatively simple terms. First, a special gravimetric antenna is used to measure the topography of spacetime at a ship's current location. It is also used to measure the topography at a desired destination. Destination topographical information is always on a delay, as it comes to the antenna only at the speed of light. Hence, the topography at a destination 1 light-year distant is already 1 light-year out of date by the time the antenna receives the data. This is where the power of math makes the STD possible. The ship's computer proceeds to perform advanced mathematical calculations based on known gravimetric phenomenon at the destination location, including distortions caused by observable masses. These calculations bridge the gap between the light-speed delayed information gathered by the ship's gravimetric antenna and any changes which may have occurred in the intervening time span. Once the destination spacetime topography has been calculated to a reasonable degree of accuracy, the transposition process begins. Large diphase projectors along the exterior of the ship begin to produce powerful graviton-doped electromagnetic fields, which alter the local spacetime topography to match the calculated topography of the destination location. Older vessels used priapic diphase projectors, which were always deployed. Modern ships have pop-up diphase projectors which are erected only when desired. The diphase projectors generate gravimetric fields along their primary phase inducers, causing the spacetime occupied by the ship to perform a transposition to the destination location. The ship then enters the most dangerous part of faster-than-light travel, as two segments of spacetime cannot occupy the same point. If the process were to stop here, the ship could be destroyed by spacetime turbulence, and would at the very least snap back to its original location. However, now the secondary phase inducers of the diphase projectors begin to engage, altering the spacetime topography at the destination location to match the spacetime topography of the origin point. Once the transposition threshold is reached, the destination spacetime snaps to the origin location, while the origin spacetime snaps to the destination location. The ship now finds itself instantaneously transported to the destination. The process of simultaneously altering two areas of spacetime, as necessitated by spatial transposition, is incredibly power-intensive. This power requirement is multiplied by the amount of mass present within two areas of spacetime. Moreover, mass localized at the destination will cause inaccuracy in the transposition calculations, possibly resulting in a rejected jump, or even the destruction of the transpositioning vessel. For this reason, it is desirable that the destination location be nearly absent of mass. Thus, transpositions tend to be engaged at a safe distance from gravity wells, where mass tends to congregate in ways impossible to accurately anticipate. Due to current computational and power limitations, civilian STD systems are limited to approximately 1 light-year jumps, while military vessels have achieved jumps in excess of 2 light-years. Longer distance travel is possible by conducting multiple jumps in succession, with the diphase projectors being degauzed between attempts. A 1-hour degauss cycle is typical on starships, allowing a civilian vessel to travel a distance of 24 light-years in a single Earth day.
Thank you, Glitch. That was very dry and informative. All right, everybody. Until next time, this is Orbital Opinions, signing out.